what we have here is a polynomial over a polynomial. So that's a rational function. So that's a polynomial and that's a polynomial. So we want to graph this rational function. So the first thing that we determine is the symmetry of this function. Is it symmetrical about the x-axis? Is it symmetrical about the y-axis? That's what we're trying to figure out here. So let's plug in negative x in for x to check for some various symmetries. So we plug in an x equals negative x. So we have negative x the whole squared minus 1. So we have negative 4 over x squared minus 1. So f of negative x is not equal to f of x, which means if you change x to negative x, it does make a difference. And that tells us that it is not symmetric about the y-axis. Next, we find the y-intercept. Y-intercept is where the graph intersects with the y-axis, which means x coordinate has to equal 0. So we plug in x equals 0. So f of x equals 4x over x squared minus 1. So if we plug in a 0 in for x, we get 4 times 0 over 0 minus 1, which is 0 over negative 1, which is equal to 0. So the graph does cross the y-axis at 0, 0. So when we plug in a 0 in for x, we get y equals 0. So x is 0 gives us y equals 0. So the graph basically passes through the origin. Now let's check for x-intercepts. To find the x-intercept, that is where the graph crosses the x-axis, we substitute y equals 0. Y is the same as f of x. So we take the function f of x equals 4x over x squared minus 1 and plug in 0 for y, that is f of x, and solve this equation. So we have a fraction equal to 0. A fraction can equal 0 only if the numerator is equal to 0, which means x equals 0. So x equals 0 is where the graph crosses the x-axis, which means when x is 0, y is 0. So in this case, there is only one x-intercept, which is also the y-intercept. So the graph crosses the origin. So its x-intercept is equal to the y-intercept. Next, we figure out if the graph has any vertical asymptotes. To find the vertical asymptotes, we take the denominator, which is x squared minus 1, and equate it to 0. So that gives us x plus 1 times x minus 1 equals 0. That is x plus 1 equals 0, x minus 1 equals 0, x equals 1, and x equals negative 1 are the vertical asymptotes. So basically, this is the coordinate axis, x equals negative 1 and x equals positive 1 are the vertical asymptotes. Next, let's see if the graph has horizontal asymptotes. So f of x is equal to 4x over x squared minus 1. So we're thinking about what would happen if x approaches either positive infinity or negative infinity. So what is the end behavior of this function? Now the degree of the numerator is less than the degree of the denominator. So by rule, we know that y equals 0, which is basically the x-axis, is a horizontal asymptote. But let's think about the end behavior of the function. At the end, the polynomial is dominated, the value of the polynomial is dominated by the leading term. So the leading term in the numerator is 4x. The leading term in the denominator is 4x. So that gives us 4 over x. We cancel one of the x's. So x over x squared is equal to 1 over x, and that's how I get a 4 over x. So what happens to 4 over x as x approaches infinity? As the denominator gets larger and larger, either in the positive or the negative infinity, the value of the function approaches 0. So that tells us that y is equal to 0 is a horizontal asymptote. Next. So we know that the graph intersects with the origin. So it either touches the origin or crosses the origin. We know that these are the vertical asymptotes. And we also know that the x-axis is a horizontal asymptote. So we need to plot a few points to kind of see what the graph looks like. So we can plot a few points between -1 and 1 to get an idea of what the shape of the graph between these two numbers is. And we can also plot a few points beyond +1 and before -1. So I've plotted a few points and I've marked them here. It's here and here. So since we know that x equals -1 is a vertical asymptote, we know that the graph as it gets closer to -1, it goes to infinity. So it crosses the x-axis, and we can assume that the same happens since x equals +1 is a vertical asymptote. It might look something like this. I've also graphed points to the right of 1, and it looks like both the points are positive. And since the x-axis is a horizontal asymptote, the graph gets closer and closer to the x-axis at the end. So that's the end behavior of the function. And since x equals +1 is a vertical asymptote, as the graph gets closer and closer to the vertical asymptotes, it goes off to positive infinity. These two red dots here are also points on the graph. And again, x equals -1 is a vertical asymptote. So when the graph gets closer to the vertical asymptote, it goes off to -infinity. And since the x-axis is a horizontal asymptote, we can assume that the graph gets closer and closer to the x-axis. And this is what the final graph looks like.